Okay, here the recording in progress, and I'll start the sharing of the screen. Okay, so we're here. I'm going to be giving you a quiz shortly. We have a buffer day, which means if I fall behind, I'll catch up, but I'm right on par. So that means I'm a little bit ahead. Okay, so I'll sneak in a little bit of 3.4. 3.4 is actually quite a challenging section. It's a little bit tougher. It's on rational functions. So I'll lecture for a while, but I wasn't going to take up the entire class period. I want you to have enough time to work on the quiz also. Okay, so remember the ground rules for the quiz. It's open everything, and it's due 11:59 p.m. tonight. So you've got more than half a day. At least those of you that are with me synchronously, you have more than half a day. Those of you watching the video, depending on when you see the video, it might be a little bit later. Okay, so here we go. All right, so first let me give you the quiz. So quiz time. It's being recorded also, so it's there, but you may want to take a screenshot or take a picture on your cell phone, as the case may be. And here we go. And I'm not sure if you can see the whole thing. I'll have to make it a little bit smaller, maybe. Okay, number one, use the zeros and n behavior to draw a rough sketch of f of x equals x plus 4, x minus 1, x minus 5. Okay, so it should not be that hard to find the zeros, right? Should be pretty obvious. And then the n behavior, go to the right of the furthest zero and go to the left of the first zero on the other side, I suppose is one way you can say it. Okay, and otherwise you can, for n behavior, you can think of plugging in a big number like 100 and plug in a number like negative 100, and that should do it, right? And then graph what happens in between. And a hint is all of these are multiplicity 1. So do you recall what happens when we have a multiplicity of 1, right? So I've practically given you the answer for number 1. Whoops, let me get this thing in focus. Number 2 also should not be that bad. Completely factor p of x equals 3x to the 4th plus 5x cubed minus 5x squared minus 5x plus 2, given that 2 of the roots are 1 and negative 2. So you don't really need to even use the rational zeros theorem, okay? They're already giving you 2 of the solutions. So you can do the long division or synthetic division. In my opinion, synthetic division is much easier. Okay, you already know that 1 works. And by the way, what does that mean about the factor, right? And they tell me that negative 2 also works. And what does it mean about the factor? In other words, the parentheses, x, blah, blah, blah. Okay, so if you do the polynomial long division or synthetic division, if you try 1, you'll get something down to 3rd degree, right? And then if you try negative 2, you'll be down to 2nd degree once you have 2nd degree factor or quadratic formula, as the case may be, right? Now in the original problem, it says completely factor. So it's 4th degree, so you should have 4 factors. So the answer is going to be parentheses, 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 parentheses. Is that right? Yes, there are 4 zeros also. I guess in the question it doesn't tell you that you have to have the 4 zeros. So it's, not necessarily, I guess. But otherwise, yeah, that's what you want to do, right? So hopefully that should be pretty straightforward. Anybody have a question on that now? Well, obviously, if you're watching the video later, you can't ask questions. That's part of the game, obviously. But for those of you that are here with me in the Zoom, does anybody want to ask anything about that? So hopefully it's fairly straightforward. Okay, so the zeros should be easy. Here, here, and here. Plot them down. N behavior, what happens when x is big? Plug in 100. Negative big, negative 100. And then you can do the sign chart stuff for the in-between up or down, or use the rule of multiplicity 1. Okay, and then again for number 2, you start off with 4th degree. They already give me 2 roots, 2 zeros. Whoops. Come on. Okay, so you know that 1 works, so divide out. You can either divide out x minus 1 and do the long division, or synthetic division, which I recommend. It's a lot shorter. Okay, then that will be depressed down to 3rd degree, and then do the same thing for -2, which means, whoops, you can divide by x plus 2, but again, it's a lot faster to do synthetic division on -2. That will get depressed down to 2nd degree. And once you have 2nd degree, quadratic formula, or maybe it factors. I won't tell you if it is or not, but hopefully you can figure that out. Okay.
Wait, did you just say, so like, and say that like the first time you would divide by x minus 1, and then once you had that answer, you divide the answer by x plus 2? Is that what you just said?
Correct. For this one, you can divide by x minus 1 if you're doing long division, but I would advise you to do synthetic division. It's easier. Which means you can just do 1 on the synthetic division. You get your 3rd degree polynomial, right? And then do -2 after that.
Huh.
Is that okay?
Yeah, no, I just I've never heard anyone say to use 2 different factors. Like, I thought you'd have to stick with the same factor the entire time. So I don't know, it's just interesting.
Yeah, so they're already giving me 2 roots, which is almost the same thing as giving you the 2 factors, because you can figure it out, obviously, if you do it the right way. Okay. All right, so that's the quiz. Due at 11:59 p.m. tonight. And now I'll introduce rational functions. But I won't be going that long necessarily. All right, so 3.4, rational functions. A rational function is the ratio of 2 polynomials. You have a polynomial divided by another polynomial. Okay, and of course, the denominator cannot be equal to 0, right? So these are all rational functions, polynomial divided by polynomial. And of course, we have to make sure the denominator is not equal to 0 in each of these situations, right? So you have to account for that. Okay, oops. This thing seems to go out of focus on me sometimes. Asymptotes. Okay, an asymptote is a line that the graph gets really, really close to. Okay. Often it doesn't touch, but that's not necessary in the definition. Okay, but a lot of our graphs won't touch an asymptote. Okay, this is considered an asymptote, a vertical asymptote. The graph gets really, really, really close to x equals a. And likewise over here, and likewise over here. Okay, so in each of these instances, they're trying to say x equals a, whatever a happens to be, is a vertical asymptote. It either shoots all the way down or shoots all the way up, either on the left side or the right side. Okay, so here it shoots up toward infinity on the right side. Here it shoots up toward infinity on the left side. Here it looks like it shoots down to -infinity on the right side. Here it's shooting down to -infinity on the left side. Okay, so all of those are considered vertical asymptotes if you have that kind of situation. Okay. And similarly, you can have a horizontal asymptote. I mean, it looks like here you have a horizontal asymptote, the x-axis, and here the x-axis is a horizontal asymptote. Okay. Page 160. Horizontal asymptote. Okay. The function approaches some number as x goes to infinity or x goes to -infinity. That means the graph goes way out to the right or it goes way out to the left. Okay. So here, when the graph goes way out to the right, the graph approaches y equals 2. And likewise, if I go way out to the left, it looks like the graph still approaches y equals 2. Right, so y equals 2 would be a horizontal asymptote. This picture looks like on both sides the graph gets close to the x-axis, which is the same thing as saying y equals 0. Okay, so we have horizontal asymptote. Right, so you could have vertical asymptotes. You could have horizontal asymptotes. You could have both. Okay, this looks like a situation where you have both. Okay, it looks like you have a vertical asymptote, and it looks like you also have a horizontal asymptote. It looks like when x goes way out to the right or way out to the left, you're getting real close to y equals 1, something like that. Okay. All right. So that's what we're up against. Okay, now, we won't do too many problems involving this, but you can also have a slant asymptote. Page 164. Okay, I'll just touch on it briefly, but slant asymptote. So instead of a horizontal or a vertical asymptote, you could approach some other slanted line. So the graph might go something like that or like that. So this might be the line, I don't know, y equals x minus 1 or something like that. That could also be an asymptote, a slant asymptote. We're not going to do that too much, but just to let you know, it is possible. And another example is something like this. Whoops. Okay, so for this particular graph, it looks like we have a vertical asymptote, x equals -3. And this happens to be the line, I guess they say y equals x minus 5. So it shoots up like that. It gets really, 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 really close to that line. And likewise over here, it gets really, 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 really close to the line over here. Okay. And we'll learn how to do stuff like that. Okay, so we could have vertical asymptotes, horizontal asymptote, and even slant asymptotes. Okay. All right, so the first thing we're going to do are the problems at the beginning. So let me give you those problems again. So we are starting 3.4. So anything I do today again is just gravy because I was originally only supposed to get up to what? Let me mark this off here. Up to 3.3. So I wasn't supposed to start 3.4 until next time. But I got buffer days. I got several buffer days until the next exam, which is on October the 8th, it looks like. Okay. And by the way, believe it or not, when we get to October 8th, that's our third exam out of 6. So by the time we reach here, we're already halfway through the course, believe it or not. Okay, so right now we're roughly 1/3 of the way through, a little bit more. Okay, so let's see, 1 to 43 odd. Okay, so let me get that for you. So page 168, 1 to 43 odd. So for the benefit of those of you that don't have the book and aren't getting it. Okay, we have that. If you see this sign stuff, that's basically doing a sign chart. I've already shown you some sign charts. Okay, so those parentheses, see how it goes paren, paren, paren. You're putting either a plus or minus. And we've played that game before already. So don't be all freaked out by that too much. It's stuff we've seen. Okay, and let's see, that's that. Okay, and how far do we have to go again? Up to 43. So some more on the next page. Yeah. And 43 is the last. So yeah, I only need to show you the left side of the book. I don't need to do anything on the right side. Yeah. Oh yeah, 37 and 39 looks like you have slant asymptotes there. Yeah, that's up to 43, and was 43 our last problem? Yes, it was. Okay, so that's about it for that. Okay, so let's get started with some of this. Okay, number 1, the graph of a rational function is given. Give the domain, range, and the vertical and horizontal asymptotes. Okay, I'll abbreviate domain with D. If we know we're talking about domain D, range R, vertical asymptote VA, horizontal asymptote HA. And you may do likewise for me on homework, quiz, test. If we know we're talking about domain and range, just put D and R. If we know we're talking about vertical asymptote, horizontal asymptote, just put VA and HA, VA and HA. Yes, okay. All right, so number 1, domain and range. Okay, so for X, it looks like X can go as far to the left and to the right as you wish, but X is not allowed to be -1. Okay, so I'm going to say for number 1, The domain is a set of all real numbers minus the set consisting of 1. Like that. And then for the range, how high and how low, well, it goes as far down as you want, it goes as far up as you want. It looks like the only y value that's excluded is 0, right? So y cannot be 0. So for the range, all real numbers minus the set consisting of 0. And yeah, to distinguish real numbers from the range, use the convention of the funny looking R for real numbers where you put 2 marks for the R. Okay, so this R, the regular R that we use in English, right? That'll mean range. The funny looking R that has 2 marks down, that's for real numbers. Okay, so domain, how far to the left and right can I go? What can X be? X can be any real number except for, oh, I'm sorry, it should be -1, isn't it? Yeah, my bad, -1. All reals except for -1. And Y can be any real number except for 0. Okay, then the va and the ha, vertical asymptote, horizontal asymptote. Okay, so X equals -1. And yeah, the vertical asymptote and the domain are closely tied together, as you might guess. Well, X cannot be -1, and the reason for that is because you have an asymptote. And ha, horizontal asymptote. In some sense, that's also tied together. It's the x-axis or y equals 0. All right, so this is the complete answer for number 1. Domain is all real numbers except for the set consisting of -1. The range is a set of all real numbers minus a set consisting of 0. Vertical asymptote, x equals -1. Horizontal asymptote, y equals 0. By the way, you might recall from your algebra, x equals a constant is always a vertical line. Y equals a constant is always a horizontal line. Right, so maybe I'll just put that down from algebra. Get this thing focused here. Algebra. X equals some constant is a vertical line. Y equals some constant is a horizontal line. So if you're asking for VA's, vertical asymptote, it's always X equals blah, blah, blah. And for ha, horizontal asymptote, your answer is always going to be Y equals blah, blah, blah. Okay, so you must put those down. Okay. All right, 3. So you got this weird thing like that, and like that, and like that. Okay, domain. How far to the left and right can X go? Well, X can go all the way to the left, it can go all the way to the right. The only numbers excluded seem to be plus or minus 1. Right? So for number 3, domain is all real numbers minus the set consisting of -1 and 1. Try to show at the same time here. Okay. How about the range? Well, for the range this time, I've got some numbers that are left out. Whoops. Okay, I can go infinitely far down. I can go infinitely up. It looks like it gets right up to, what is that, 1? Then I have nothing between 1 and 2, and then 2 and higher, including 2. Right, so 2 is included, so that should get a bracket. It looks like 1 is excluded, so that should get a parenthesis. Okay, so for the range, I'm going to go -infinity, -infinity to 1, parenthesis, union bracket 2 to infinity. See if I can put that there with you. Okay, so I can go all the way down. I come up to 1, don't quite reach 1, so parenthesis on 1. Nothing between 1 and 2. And then I start at 2, including 2, bracket 2, and then all the way up infinity. Okay, this should be a parenthesis right there. Okay, vertical asymptote, two of them, here and here. So x equals -1, x equals 1. X equals -1, x equals 1. So two VAs, and it looks like there's only one horizontal asymptote, which is y equals 1, right? Y equals 1. So again, when you write your vertical asymptote, it should always be x equals blah, blah, blah. X equals blah, blah, blah. When you do the horizontal asymptote, it should always be y equals whatever. Okay. All right, then 5 looks like this. So it goes like this, and then it just cuts off here, and then there's nothing over here, it looks like. So domain number 5. Well, I can go all the way out to the left. It looks like I've got a wall here at x equals 1, and I don't quite reach 1, and there's nothing bigger than that. So the domain is from -infinity up to 1 parenthesis. So domain, -infinity, 1 parenthesis. So you don't actually reach 1, but you can get 0.9999999, just not 1, and nothing beyond that. Range, how high and how low does it go? And are there any excluded values? It goes infinitely far down. It goes infinitely up, and doesn't look like there's anything missing. So the range is all real numbers. Okay. By the way, yes, you could write all real numbers as -infinity to infinity, right? Because you're going all the way to the left and you're going all the way to the right. I prefer this, it's a little bit easier. Okay, vertical asymptote. It looks like over here. So where's here? X equals 1. And horizontal asymptote. Well, doesn't look like we approach any horizontal asymptote, so none. Okay. All right, how do you do something like number 7? So let's see, what time is it? It's only 9:35. I was going to do number 7 and maybe stop there. Okay, it looks kind of scary, but it is something that we've attacked before, hopefully. Completed the table to determine the vertical and horizontal asymptotes of the rational function, and so on. Okay, so how do you do that? I'll show you that. 7. 7 for you. F of x equals x plus 1, x minus 1, whatever. Okay. So let me write this down for you. X plus 1, x minus 1 over x minus 2, whoops, x plus 2. Okay, you can tell right away x equals 2 is not allowed. X equals -2 is not allowed. Okay, so that's the reason why. Notice you have -2 and +2 here. Okay, and what's all this minus and plus business? Okay, you'll get a lot more of this in calculus. In fact, you're getting a little taste of calculus now. The minus sign means you're coming from the left side. The plus sign means you're coming from the right side. Okay, so let me write down x approaches 2 minus x approaches 2 from the left. That means a number like 1.999. So x arrow 2 with a negative superscript, almost like an exponent. we say x approaches 2 from the left, that means you plug in a number like 1.999. X arrow 2 with a plus, the language is x approaches 2 from the right. X approaches 2 from the right. You're a little bit higher than 2. That's a number like 2.001. Okay. You're really getting a taste of calculus now, essentially. Okay, so when they put the minus sign, you're a little bit to the left of 2, like 1.999. X approaches 2 from the right. X arrow 2 with a plus. X approaches 2 from the right. That's like 2.001. This is not necessarily an exact value. Okay. It could be 2.01, 2.0001, right? The concept is that you're very close. X approaches infinity. We say x approaches infinity. Plug in a big number. Okay. Something much bigger than anything that you see there. So, there's no fixed number. For most of our problems, maybe like 1,000. Can you guess what that is? X approaches negative infinity. X approaches negative infinity. Plug in a large negative. So maybe like negative 1,000. Something like that. Okay. So how do we do weird stuff like this? Right. So I'm going to reproduce this. So I don't corrupt my book too much. X approaches negative 2 from the, oops, supposed to be from the left. Right. 2 left. 2 right. Infinity. Negative infinity. 1, 2, 3, 4, 5, 6. I think I did it right. Okay. So this, I'm going to say 1,000. Negative 1,000. A little bit to the left of 2, 1.99. A little bit to the right of 2, 2.01. Or you can say 2.001 or 2.001. Okay, this one's a little bit tricky. A little bit to the left of negative 2, negative 2.01. A little bit to the right of negative 2 is negative 1.99. Okay. Fraction bar, fraction bar, fraction bar, fraction bar, fraction bar, fraction bar. Okay. The fraction bars that I have, I can get this thing a bit focused again. It's equivalent to these parentheses. We're just going to put a sign. Okay. And for reference, I should rewrite the function. X plus 1, x minus 1 over x minus 2, x plus 2. Comes out funny here. These are ones. Okay, so I plug in negative 2. Negative, 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 negative 2.01 is negative. So these 4 negatives are just like that. You would put minus, minus, minus. I know what I'll do. I can just write it in for this one problem. Minus, 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 minus. Okay, that's what they want. 4 minuses means the whole thing is positive. Negative 1.99. Negative, negative, negative. Negative 1.99 plus 2 is positive. All right, so that makes the whole thing negative. 1.99, positive, positive. Let's see, negative, positive. 3 positives, 1 negative, so the whole thing is negative. 2.01, 2.01, positive, 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 positive. Okay, 1,000 and negative 1,000. I'll write it this time. Okay. They actually do a sign chart here. The sign chart doesn't really help that much, but let me actually work it out. If I plug in 1,000, I have 1,001, 999. This would become what, 998 times 1,002, right? It's practically 1. Okay, there's not much difference between these two numbers. I don't need a calculator. 1,001 and 998 are almost the same thing. 999 and 1,002 are almost the same thing. It's roughly 1, which means y equals 1 is going to become an asymptote. Something similar here. If I plug in negative 1,000, I have negative 999, negative 1,001 divided by what? Negative 1,002 times negative 998. It's also approximately 1. You don't need a calculator for that. These are almost the same, right? There isn't much difference between 999 and 1,002. There isn't much difference between 1,001 and 998. There's 4 of these. So approximately 1, which means y equals 1 is going to be a horizontal asymptote. Okay. So here's how the sketch would work, and then I'll quit. So VA, vertical asymptote at -2 and +2. 1, 2, 3, 1, 2, 3. Okay. Yeah, by the way, we could figure out what happens if I plug in 0. Let's see. We can do that. F of 0 is what? -1 divided by -4, or 1/4. So 0, 1/4, somewhere there.
Wait, can you explain really quick why why these are asymptotes in your table? Like, how do you know those are asymptotes?
Okay, x equals 2 and x equals -2 are not defined.
Oh yeah, I get. Okay,
So
that's
they're
what
automatically going to become asymptotes,
okay, no, I see
Okay.
that. Okay,
right? And what I said is actually not quite true. If there's a cancellation, I'll talk about that next week. But let's say there was an x minus 2 also on top, it would cancel out, and then x equals 2 would not be an asymptote.
yeah,
We'll
I was
talk
actually
about that.
talking about the horizontal asymptote equaling y equals 1. If you go down to the table, that's what I was confused about. Because that so at when x equals 1,000, it's roughly equals to 1.
Correct. And -1,000 also gives me roughly 1. We'll learn techniques how to figure that out faster, but essentially, so the idea is 1,000 is so big, it has almost no effect if I add or subtract 1, or if I add or subtract 2. Okay, so if you have 1,000 grains of pebble, you lose 1 or you add 1, you still have 1,000 basically, right? You lose 2 or you add 2, you still basically have 1,000. So when you divide, it's essentially 1. Okay. Not exactly, but almost 1. So that causes y equals 1 to be an asymptote. So let me go like that. So here's my horizontal asymptote, vertical asymptote, vertical asymptote. Okay, so let's look at what happens at -2, a little bit to the left of -2, positive. To the right of -2, negative. And then what happens near x equals 2? On the left side, negative, which really means it goes toward negative infinity. Slightly bigger than 2, positive. So it's like that. And then end behavior, they both approach y equals 1. All right, so this thing will shoot up like that. Come down. Asymptote. Asymptote. So that's a very rough sketch of what this thing's going to look like. So you can see what's involved for these kind of problems. So that was 7, and I'm sure 9 is similar. And this is what we're up against for next week also. But remember, this was extra. I wasn't supposed to even start until Monday, so we're just getting slightly ahead over here. Okay. All right, I was going to stop right there unless anybody has a question, and I'll let you loose and get going on the quiz from here. Yeah, fine.
So I'm going back to this graphing part. So when we look at as x approaches -2 from the left, and that being positive, we know it's going towards the vertical asymptote x of -2, going up, and then the next one is -2 approaching from the
right side. Mm-hmm.
The right side, yeah. It's minus. So that means it's going away from -2, but since it's an asymptote, we know it just goes like that.
It means as I approach -2 coming from the right side, it drops toward negative infinity.
Oh, I see that. Okay, I see that now. Yeah.
Yeah, we're not allowed to cross. So.
Yeah, and so the that little part, like to the left of -2 on top, I see why it goes up towards -2, but are we just assuming that that means that it also goes down to the right? I guess you have to assume that, huh?
Yeah, I'm not sure if you're asking if on one side it's infinity, is the other side negative infinity, not automatically. So you do have to analyze both sides. It does happen a lot, but you could go to infinity on both sides, or you can go to negative infinity on both sides.
No, I mean, no, just the very left portion at the top. The top, I see how our graph tells us to go towards the asymptote at -2, but on the opposite side of that line.
Over here?
Yeah, just go now, trace down it, going towards negative infinity of x. Yeah, that part. We know that just by the shape of it going towards infinity, right?
I mean, I got this from here. X approaches -2 from the right. So if I plug in -1.99, which is a little bit bigger than -2, I did my sign chart. And by the way, this plus minus stuff is exactly what they mean by those, all that parentheses stuff. It came out to be negative. So that tells me I'm going down toward negative infinity if I'm a little bit to the right of the VA, the vertical asymptote. Okay, and then I did the same thing, same analysis with +2. So coming on the 1.99 side, I'm going like that. And at the 2.01 side, I'm going like that. And then the two extremes, if I plug in 1,000 or -1,000, I'm very close to 1. So I said, okay, it's going like that, and it's going like that. And side note, this happens to be an even function. It does have symmetry with respect to the y-axis. You don't really need that for this problem, but it's extra. So yeah. Okay, any questions? Otherwise, we're done. All right, that's it for today. So have a good weekend. Quiz due at 11:59, and we'll see you next time. Okay.
Thank you, you too.
All right, thank you. Bye, everybody.